Once upon a time, the communication, for example, from New Delhi was there maximum up to Agra or Jaipur via radio. Now you can communicate via radio from New Delhi to say Trivandrum or even Sri Lanka. This is possible because of skywaves. Coming into details, initially what happened was radios which were used were line of sight waves. इसका मतलब क्या है? For example, if this is the earth surface, I have a transmitter here. Now, for example, if there is an aircraft here, second aircraft here, third aircraft here. Now, the line of sight waves are those which go directly from the transmitter to the aircraft, or they are ground reflected in this way, or sometimes surface waves also go like this. But I cannot send these transmissions to this aircraft because it cannot pass through the earth, right? So the transmission range was very limited. These waves, surface wave, direct wave and ground reflected wave, these are together called as ground waves. So ground wave has very less range. For example, if the transmitter or antenna is in Delhi, the range is only till Agra. One more problem with these waves, ground waves, is attenuation. So what is attenuation? Now, if you take a switchboard in your house, say these are switches and there is a plug point. There are three ports in this plug point. One is a positive port, second one is a negative port. What is this port? The top mota wala. This is called as earthing port. So this plug point is in this room, another plug point is in another room. All these earthing points are connected via a mota wire and is buried inside the earth. We do call this as earthing. Why? If there is any short circuit or if there is an over voltage, the excess amount of the voltage will be absorbed into the earth. Earth attracts electricity. The same way, when this wave is propagating, as it comes close to the earth absorbs some amount of energy into it, and the power of the wave decreases. So the wave cannot travel much longer distances when it is traveling close to earth. So these waves, surface wave, by the way, the classification of the surface wave, direct wave, ground reflected wave, space waves, I made a separate video which explains in detail. Just go through it, or just remember all these together are called as ground waves. So these ground waves travel close to the earth and the earth attracts electricity. As the wave is just an electromagnetic energy, it is getting attenuated. Understood? That is one reason the range of ground waves is less. One more point about attenuation is, see, what is frequency of a wave? Number of cycles that pass one point in 1 second. What happens if the frequency of a wave is more? When the frequency of wave is more, it comes to close to the earth or ground more frequently, so it gets more attenuation. and so the range is decreased. So more frequency of ground wave, range is decreased. Initially this was the case. That's why the communication between the aircrafts were limited to a very small range, max up to 200 nautical miles maximum, or say from Delhi to Agra, or say Jaipur. That's all. This is when they discovered skywaves and we started using it. Now we can talk long distances using these skywaves, and we will go in detail what are these skywaves and how we communicate using them. Before going into skywaves, I want you to understand a few things about our atmosphere. This is the earth. See, this is the sun. Now in atmosphere there is one layer called as ionosphere. What happens is sun's rays come and hit molecules in this ionosphere. What happens is, in a molecule or in an atom in a molecule has a nucleus and then electrons around it, like this, rotating, sorry, revolving. Now when the sun's rays come and hit this electron, a few electrons is displaced and this becomes a positive ion. So here in this layer atoms exist as positive ions and electrons, which is negative. So as the ions, as the molecules exist in the form of ions, this layer is called as ionosphere. Now what people observed was, see, these were line of sight waves getting received maximum at 200 nautical miles. Sometimes someone sitting in Sri Lanka, for example, transmission is from Delhi and this is Jaipur. Someone sitting in Sri Lanka could monitor what was happening in Delhi, and then it was reported, and then it got key like how is this happening. Actually, what happened was these waves were going to ionosphere and getting reflected back at a very long distance. This could be around 1000 nautical miles. Now let us see why this is happening. This is happening due to two reasons. Number one, see, take two magnets, North Pole, and bring them close. They repel each other. Or take a magnet, North Pole and South Pole of another magnet, and bring them close. They will attract each other. So, this wave is nothing but electromagnetic energy. And these are ions, positive ions and negative ions. There exists some kind of electromagnetism. So, these are repelled down. And moreover, in this layer, due to the difference in the density, so, close to earth air density is more, and above or farther or at a higher level from earth air density is less. So you all studied in say +2 the concept of total internal reflection. Whenever a light wave passes from more dense medium to less dense medium and it hits at a critical angle, sorry, and hits at a critical angle, it initially undergoes refraction. Matlab, it will not travel in this path, it will travel in this path. And then once it reaches a critical angle, it undergoes total internal reflection. Matlab, it is totally reflected back. This phenomena of which helps sky waves to come back at longer distances is called as total internal reflection. I said two reasons. First one was due to the electromagnetic properties of the ionosphere. Second one was because of the change in the density. Below was more density, above was high density. It was hitting the ionosphere at some angle. That's why the wave was initially refracted. It did not go in this path, but it went in this path. But when the angle of hitting the ionosphere crossed a critical angle, the wave is completely reflected back to Earth. This phenomenon is called as total internal reflection. So this is why we are getting sky waves back to Earth. Now let's go further ahead and see in detail about the ionosphere. Say this is Earth again. Ionosphere exists in three layers. First layer is called as D layer. It is thin, not very thick. This layer is called D layer. It exists at a height of 75 kilometers. See, all these are questions in DGCA navigation exam. So pay attention if you are going for exam. Next layer is a bit thicker than this layer. This layer is called as E layer. It exists at a height of 125 kilometers. The next layer is called as F layer. It is a very thick layer and is divided into two parts, F1 and F2. It exists at a height of 225 kilometers. Understood? Now, I want you to remember this. This E layer is also called as Kennelly Heaviside. Kennelly Heaviside. Spelling might be wrong. Just cross check in your Oxford navigation textbook. The F layer is also called as Appleton layer. So why is this divided into three layers and what is the importance? Now, going into details, if this is the transmitter, first, and say this is the transmitter in Delhi and this is Jaipur. So line of sight waves reached only here, all the ground waves का range था इधर तक. Now this was Mumbai, this was Hyderabad, this was Chennai. Now what they observed was the first wave to go to ionosphere and get reflected back, or total internal reflection, was 500 kilohertz. Below this 500 kilohertz, the wave didn't come back. What happens if you send a wave of higher frequency? This wave used to escape this. But if you send at an angle, this wave, for example, this is a 2 megahertz wave. This wave, when sent at a more critical angle, used to escape the D layer but used to come back from E layer and get reflected to a longer distance. So D layer reflects back a wave of 500 kilohertz. to a distance of 800 nautical miles. E layer reflects a wave of 2 megahertz to a distance of 1350 nautical miles. Same way, if you send another wave at more critical angle, it will get reflected back to a longer distance, which is around 1800 nautical miles. So the frequency of the wave, maximum wave that is reflected back by F layer is 30 megahertz. What happens if you send 31 megahertz at any critical angle you send? If the wave is 31 megahertz, it will simply escape into space. It is a loss of wave. So the the minimum frequency which is reflected back is 500 kilohertz. The maximum frequency is 30 megahertz. Now the minimum frequency is reflected back by D layer. Maximum frequency is reflected back by F layer. Now you know between here and here the E layer reflected at 800 nautical miles. Sorry, D layer. E 1350, F 1800. So we can say the sky waves range is between 800 से start होता है. So if you are living at 750 nautical miles, if your aircraft is at 750 nautical miles or here, you will not receive a sky wave because it has skipped this much distance and went to Mumbai. That is the minimum distance it can transmit. Understood? So the range of sky waves is 800 nautical miles to 1800 nautical miles. Okay. Now you understood what is ionosphere, how is it formed, why is the sky wave reflected back, and how we are able to communicate from Delhi to Chennai using these radios and using these sky waves, and what is the frequency which they are reflected back, what are the three layers D, E, F, and what are the other names, E ka Kennedy Heaviside, F ka Appleton layer, and what are the heights, D layer at 75, E layer at 125, F layer at 225 kilometers. These are all questions in DGCA EXAM. Now, let me go a bit deeper into concepts. We will see what is number 1, skip distance. Number 2, what is dead space. Now, if you take this earth, this is the transmitter. From transmitter, the line of sight waves travel to this aircraft. Understood? Suppose there are 3 aircraft traveling towards this transmitter. Say this is in Delhi. So if you transmit a wave, it went till, say this is Jaipur, and got attenuated. So this is ground wave ka distance. Ground wave. Now, see this is D layer. You have sent the wave at some critical angle and it came back to this aircraft. This is say Mumbai. So this aircraft did not receive line of sight or ground wave transmission because of attenuation. Also, it did not receive the sky wave because the sky wave skipped so much. Itna distance skip kar diya. It got received only at Mumbai. So this space between this aircraft and this aircraft, where neither ground wave nor sky wave. मतलब इधर ग्राउंड वेव भी नहीं आया, स्काई वेव भी नहीं आया. दिस space is called as dead space. Now, see, this sky wave traveled from transmitter to ionosphere and directly from ionosphere to Mumbai. This distance which this sky wave skipped, मतलब between कितना भी aircrafts है, they did not receive a sky wave, but the aircraft in the Mumbai received it. That distance is called as skip distance because this sky wave skipped so much. Skip distance. Understood? So, dead space is space where ground waves are not received and also sky waves. Skip distance is the distance which the sky wave skips. Now, coming to the last concept of sky waves. Question. What happens to number 1 critical angle? This slide is very important for navigation DGCA exam. At least one question is expected from this slide every time. What happens to critical angle? What happens to number 2 skip distance? Number 3, what happens to dead space if the frequency of wave is increased? Let us see the answers. See, this is the earth, this is the transmitter. You know, if frequency is increased, it is coming closer to earth multiple times, right? So it is getting attenuated. So initially when lower frequency was there, the signal was traveling till here, but at higher frequency the signal got attenuated here only. Okay. Now we will see what happens to sky wave. You know, at 500 kilohertz the sky wave came back here. At 2 megahertz at a higher frequency it was reflected back to a longer distance, right? So now, and also at a more critical angle than this. So as frequency of wave increase, critical angle is increased. I will write answers in this color. Is increased. Skip distance. So frequency is increased. Initially it was received at 800 nautical miles. Now it is being received at 1350 nautical miles. So skip distance increases. Now what happens to dead space? See, this is the dead space, right? Where ground waves stop. And the first sky wave gets received. This is the dead space. इधर कोई सिग्नल नहीं रिसीव होता. So as the frequency increase, the ground waves get attenuated and the dead space is increased in this direction. इधर तक ही आता है सिग्नल, frequency ज़्यादा है ना, ground पे चला जाता है, wave gets attenuated. So dead space increased in this direction. Now if the frequency is increased, the wave is also skipped a lot of distance, right? So dead space increased in this direction also. So dead space increases in both directions. So critical angle, so if the frequency of wave is increased, critical angle is increased because this wave was 500 kilohertz, this wave is 2 megahertz. Skip distance is increased. 500 kilohertz का इधर आता था 800 पे, 1350 पे आ रहा है 2 megahertz का. So skip distance is increased. So dead space is increased in both directions. This I have explained. And coming to the last and final question of this topic. what happens to same question. Number 1, critical angle. Number 2, skip distance. Number 3, dead space. As the power of wave increases. This is the question. Now, what is power of the wave? See, take this as Earth. Initially, a wave was traveling like this because surface wave. Because it was coming close to the Earth, some amount of power was getting lost. Now, we initially example it was like 1000 watts per radio wave or transmission. Now we made it 200 watts per transmission. So there is more power in it. Even though it loses power till here, but still there is more power because it was like 2000 watts per. So it will go further forward. So if the power is increased, distance a ground wave travels increases. Okay, but see the reflection from the ionosphere, this is D layer, is dependent only on frequency. Here, this is a 500 kilohertz ka frequency with 1000 watts of transmission. It got received in from Delhi to say this is Mumbai. Even though you send next wave as 500 kilohertz only, but this time 2000 watts, still it will be received here only because the critical angle and skip distance doesn't depend on power, it depends only on frequency. So critical angle and skip distance depend only on frequency, so they will not change with increase in power. So critical angle will be same, skip distance will be same. See, skip distance is between, sorry, now we'll talk about dead space. Dead space is between where the ground wave reaches maximum and then the first sky wave is received. That is where no waves are received. But if you increase the power of transmission, you know that distance a ground wave travels increases. So the dead space decreases, but it will decrease only from the transmitter end. Since the skip distance is not dependent on the power. Understood? So the dead space decreases, but only from transmitter end. This is all about skywave except one point. See, this was the table I was trying to explain. As frequency increases, what happens to critical angle, skip distance, dead space. Same thing, same thing. As power increases, what happens to critical angle, skip distance, dead space. Now, this is not related to this topic. This is related to this topic. Last 1 minute, bear with me, and I am done with the topic. And I hope you score 1 to 2 marks from this topic in DGCA exam. So let me take back to the sun wala slide. Yeah. See, now this ionosphere exists because of sun, right? Sun rays were coming and then displacing the electrons, and it was existing. But at dawn and dusk, early mornings and evenings, there is a lot of fluctuation between the sun's rays. It will be coming less, it will suddenly be coming less. So this D layer will keep on moving up and down, depends on the ionization, depends on the power of the sun. So the sky waves show very abnormal these things. They interfere between the direct waves. Sometimes they will come like this, sometimes they will come here only, sometimes they will go here only. So it will interfere with other waves. Okay, so if the question is like maximum interference is at dawn and dusk. Okay, what happens in the night? What happens in the night? There is no sun, so this D layer entirely vanishes, and only E layer and F layer exists. E, F only during night. There is a very big topic called night effect. So my next video will be on this night effect. Subscribe to the channel Doc.PILOT10 Aviation Academy. Enjoy. All the best.